So section 4.4, we are going to learn something that is very useful, very, very important to do the probability calculation. The first one we are going to learn is we call this continuous. You will see that it's very intuitively understandable. So continuous, say we have from point A to point B, there are two ways, right? So you can understand that's like from Los Angeles to Irvine, right? For example, there are two choices. You can go freeway number 5 or go to freeway 4 or 5, okay? Then from Irvine to, let me see, I'm trying to see what's the C would be, maybe Temecula, right? So from Irvine to Temecula, you may have 3 choices, right? You may use the 5 and then use some other route, or you can go to 15, something, right? So you say you have 3 ways, right? And then my question is, how many different ways we have from A to C, from Los Angeles to Temecula, like that, right? So from this question here, I mean, we can actually literally list all the possible choice we have, right? We can take 1 and X. It's like we are using the freeway 5 and then 5 plus the other route, right? Or using the 2X, that's like a freeway 4 or 5, and then using the 5, go to Temecula, like that. So we can write down 1X, 1Y, 1Z, right? Similarly, 2X, 2Y, 2Z. So how many choices here we have? Altogether, we have 6, right? And another way to get a 6, because of what? Because from A to B, we have 2 choices. From B to C, we have 3 choices. And then we simply multiply those possible choices together. Because you can consider this as like the step by step, right? That's how many total possible ways. Okay, so what if someone say, can I continue like from C to D, D to E, right? Similarly. So if you have a sequence of events, right, you can continue that way. So which give us the fundamental continuous, right? Say you have a sequence of n events. The first event, you have K1 possibilities. So in this case, the first event from A to B, you have 2 possibilities, K1 equal to 2, right? Second event, you have K2 possibilities. So in our example, from B to C, we have 3 cases. And we can continue, right? C to D, D to E, and so on, right? At the end, nth event has a Kn possibility. Our question is, from the first one to the last one, how many possible events total, right? How many total possible choice? So we are going to have, we simply multiply them together, K1 multiplied by K2 multiplied by Kn. That's it. Everybody? That's very straightforward, right? No fancy complex calculation yet. Let's use some example to help us understand better. So if I toss a coin and I roll a die, how many different outcomes we can get, right? So let's see, in terms of the coin, if we toss the coin, how many possible outcomes we have? We have 2, right? So it's head or tail, that's the possible outcome. And then if we roll a dice, how many possible outcomes we can get? 1, 2, 3, 4, 5, 6. So 6 possible choice, right? And in terms of when we combine those 2 events together, how many possible choice we have? We simply multiply them together. It's like a sequence of events, everybody, right? 2 multiplied by 6, you got 12.
Professor?
Yeah.
So the red line on the top right-hand side, that's K1 times K2?
That's right.
Okay.
K1 is the how many possible choice. Like in this example, the first event, K1 is equal to what? 2. K2, the second event, right? They have a 3 choice. So in our previous example is 2 multiplied by 3. So when we put this in general, what's the formula look like? K1 multiply K2, right? And if you have more events, you continue to multiply them. Is that clear?
Yes, sir.
Now, let's use more examples to help us understand it better, right? So some manager want to make this 6 digits ID for her employee. Okay, so we are asking how many different ID the manager can have, right? And if the manager can use the digits 1, 2, 3, 4, 5, 6, and allow repetition, right? What does that mean? Let's try to understand the question first, right? So we have try to make the 6 digits ID. So we have a 6 position, right? 1, 2, 3, 4, 5, 6, right? The first one, if the manager can use the digits 1, 2, 3, 4, 5, 6, and allow repetition, right? So everybody, how many choice for the first digits? We can choose 1 out of those 6, right? 6 choice. How many choice for the second one, right? We can choose 1 out of those 6 because they allow repetition, also 6, right? How many choice for the third one? The same. Everybody, you see, they simply multiply them together. The fundamental counting rules, right? Everybody, right? Multiply by 6, continue to multiply by 6. The result will be 6 to the 6th power. That's the answer we have. Now, what if no repetition, right? So that's the tricky part, everybody. What if there's no repetition, right? Let's still do that step by step, right? So how many choice for the first digits, right? He or she can use, they choose 1 out of the 6. How many choice? 6 choice, right? Now the question is for the second digits, right? Because no repetition allowed. So that means the first number cannot be reused. So how many number left? 5 number left, right? So choose 1 out of those 5. What's that? How many choice? 5. Follow me, right? And the third digits, right? Because we have chosen 2 number already, we cannot reuse that 2 numbers, right? So how many choice left? 4. We choose 1 out of those 4. We put 4 choice here, right? Same as this one, we choose 1 out of the 3. 1 out of the 2, right? Here you have chosen 5 number already. There's only 1 left. No other choice. You only have 1 choice here. Everybody? So that's the answer we are getting if there's no repetition allowed. Okay, so for this notation here, we want to introduce some spatial notation. Everybody? 1, 2, when we continue to multiply them, right? So 1, 2, 3, 4, 5, 6 at the end. What is our, we want to introduce a short notation for that. We call this 6 factorial. Everybody, 6 factorial. So this is like expression mark, is right? Everybody, this one here, right? This one here. Well, in mathematics, we call this factorial. Okay, that's the notation we are using for our class. Now, some other examples, when we say, like, for example, 3 factorial, what does that mean? Right? So you simply 1 multiplied by 2 multiplied by 3, right? Always starting from 1 and with the last number showing up here, right? So if we say n factorial, what does that mean? That means we start from 1, continue multiply by 2, up to multiply by n. Is that clear, everybody? So,
Wait, Professor, so we're not going backwards, we're going forwards?
either way, you can go backwards or you can go forward. Is that right? Either way is fine, as long as you know For example, if I ask you what is 4 factorial, do you know what I mean?
You have 4, 3, 2, 1, and they're all multiplying.
That's totally fine. You want to go backward, that's totally fine.
Oh,
Or
I
you
see, I
want to
see.
go forward, 1, 2, 3, 4, that's also okay. Are we good? They are equal to each other, right? So, I mean, 1, 2, 3, 4 multiplied them together is the same as 4 multiplied by 3 multiplied by 2 multiplied by 1, the same. Doesn't matter, right? Doesn't matter. Okay, now there's a special situation I do want to point out here is for the 1 factorial, right? 1 factorial, what is the answer for that? 1 factorial. So we know 1 factorial is we start as 1, right? Also, we end at 1. So 1, I mean, it's only 1 left. It is equal to 1. No other choice, right? That's okay. The question is, how about 0 factorial, everybody? Right? That 0 factorial here, right? This 0 factorial here is not that straightforward, right? So temporarily, we can consider this 0 factorial is kind of like a defined, has to be equal to 1. Everybody, 0 factorial is not equal to 0, okay? Why? Because later on, you will see an example. If we say define 0 factorial equal to 0, we will get a big trouble later. Okay, so here we kind of define 0 factorial equal to 1 is the same as 1 factorial. Now we will have some examples coming, explain why 0 factorial has to be equal to 1, cannot be equal to 0. Okay. Let me erase that. What we have here, all right. So this to give you the concept of factorial, okay? Now we are going to know one of the most important concepts. We call this permutation. Permutation. So in this case, we are putting those objects together and the order matters, right? Which one first, which one second, it matters. So that's the permutation, one of the 2 most important concepts, right? In the class, usually you will study more if you study combinatorics. There's one mathematics subject called combinatorics. So pretty much in that class, they simply talk about the permutation a lot, right? And another case when we don't care about the order, okay? So permutation, what does that mean? That means you put all those subjects together, which one first, which one second, that matters, okay? So how many cases we will get? Let's use some example here to help you understand what do we mean by permutation, okay? So say some manager want to visit 5 offices in order, right? Those are the keywords. Usually you see that, right? Which one first, which one second, right? So how many possible outcomes, right? So in that case, like I have 2 cases here if you compare that, right? Say that manager want to visit, like say we have A, B, C, D, E, 5 different like offices, right? And that manager want to visit A first, B second, and so on, right? That's one outcome, one case. Compare with another case, the manager want to visit B first and then A. So you see that they switch, is that right? All the other C, D, E are the same. So because of A, B, they are put into different order. That means we consider those 2 cases here, right? They are different cases. So we will count this as 2 cases because they are different. Because they are different. Okay. So in that case, back to our question, right? That manager want to visit 5 offices in order. How many possible outcomes, right? So let's do 5 position. 1, 2, 3, 4, 5. Everybody, whenever we have those questions, right? We are trying to do that step by step. How many choice for the first position, right? For the manager to visit. How many choice for the manager? So he or she can choose 1 out of the 5. Is that right? Because the first one. Now, how many choice for the second one here? Because he or she already visited 1, right? There are 4 left. Everybody, you see? It's kind of implied there is no repetition allowed here. You see, right? Similarly, if you visited 2 already, there are 3 left. How many choice for the third one? You had choose 1 out of the 3, right? Fourth one, choose 1 out of the 2. Last one, you pretty much have no choice because you only have 1 left. What's the answer for that? You multiply these together and we can use the notation. What do we call this? 5 factorial. Everybody? Right? 5 factorial. That's the answer. Let's get one more example so you understand better what I'm talking about here. Let's see. What if the manager just want to visit 3 out of the 5 places and in order, right? In order. Okay, so you have 1, 2, 3, right? So how many choices for the manager have? Everybody, let's ask ourselves, right? How many choices for the first position for the manager? Choose 1 out of 5, right? Second one, because he or she already visited 1, right? 4 left. Third one, because he or she already visited 2 of them, 3 left, right? Fundamental counting rule multiplied. All right. Do we have to continue to multiply? No. Why? Because in the question, they simply want to visit 3. We have a visited 3 already. We don't need to continue. Follow me? Right? So the answer is 4, 5, 3. Multiply them together. Right? And then I was trying to put that in a kind of a strange way, right? You may wonder, why do I put this way? Right? Let's ask ourselves. First, do they equal to each other here? Do they equal? Right? This part here, do they equal to each other? 5 multiplied by 4 multiplied by 3 is equal to this part here? Yes, they do, because these two parts got cancelled. They do equal to each other, is that right? The question is, why do we want to put that way here? Okay, now, if I put this way, I can write this down as 1 multiplied by 2 up to multiplied by 5 as, everybody, we just learned this, 5 factorial, right? And then this is 1 multiplied by 2. We know what's that? 2 factorial. And instead of writing 2, I'm writing 5 minus 3. Everybody, you see? Because that's all the possible information we are given, right? So the manager want to visit 3 out of 5. So we are using all 5 and 3 we have, those information. So that's how many cases, how many outcome we have. Okay, so now this to give us how many outcome if we want to choose 3 out of 5, right? We simply write down that formula. Everybody? We can write down this formula directly, right? 5 factorial divided by 5 minus 3 bracket factorial. Simple, easy. Now, let me ask ourselves another question, right? Now, say I want to visit 6 out of line places in order. Everybody? Right? So the manager want to visit 6 out of a total 9 places in order, right? So you have A, B, C, D, E, F, G, H, I, like 9 of them, right? But you only want to visit 6 of them. What's the answer? We can write down because of that hint here give us, right? Everybody? So previously 3 out of 5, we can write down the answer here directly. 5 factorial divided by 5 minus 3 factorial. Everybody, if you care about the exam, right, pay attention here. Now, if I change the question, right, any other numbers, if I want to visit 6 out of a total 9, what's the answer? Should it be 9 factorial, right? So previously is 5 factorial, right? Divided by 9 minus 6 factorial. Follow me? That's right. I see someone was had the right answer. Yeah, okay. So 9 minus 6, that's a 3, right? 3 factorial. So you can plug into the calculation, right? So what's the benefit we are getting using this way? This way, we can write down the answer directly. You see, any complex numbers, right? Even like 600 out of 900. How many possible choice we have? Easy,
Yes,
straightforward.
sir.
Yeah.
So the denominator, the numerator, how come we don't include 6 factorial? We just focus on 9 factorial.
Do you see we have, when we do this step by step, we got this one. Is that clear? Right?
Mhm.
So we got first choice, how many, first position, how many choice? 5, right? They have 5 choice. Second one, 4. Third one, 3. And then we read them this way. Follow me? Right? Now, when we write down that, I consider this is a 5 factorial in the numerator. Follow me? In the denominator is 2 factorial. Is that right? So in other
Yes.
words, in the denominator, there's nothing about the 3 factorial. Right? So the question is, how do we get these 2, right? How do we get these 2? We got these 2 from the 5 minus 3.
Yes.
So you don't have to worry about like the 3 factorial in the denominator. No, this case here, no, right? So we can generalize our formula now. Say you want to select, let's see, let me erase. You want to select altogether n subjects, right? Out of those total n subjects, you want to select R of them. You want to select R of them. How many possible choice we have? So in other words, we are selecting R out of n, right? Previously, it's like a 3 out of 5. Everybody, if you want to make sure you are plugged into the right formula, right? So previously, if I want to choose 3 out of 5, what's the results, right? It's 5 factorial divided by 5 minus 3 factorial. Follow me? Now, right now is R objects out of a total n. So in the denominator, right? Numerator is n factorial, previously 5 factorial. Now is n factorial. In the denominator is the 5 minus 3. Here is n minus r, bracket factorial. Follow me? So that's what we say, how many cases, if you want to select the R objects out of a total n, put them together, right? And the order matters. So that's what we call permutation rule. That's the formula we require for this class, everybody. Make sure you feel comfortable, right? Work on this formula here.
Will we be required to solve for the factorials?
Yeah. So for example, like when we have 5 minus 3 factorial, what's that mean, right?
So 5 factorial, 5 times 4 times 3 times 2 times 1. And that equals like a result, right?
Yeah,
so,
5 factorial is equal to that piece. Yeah, 5 factorial. Yeah.
So then the answer is 5 factorial, the answer to that equation, over, divided by 2 factorial, the answer, which would be 2, right?
Yeah. So this denominator, numerator divided by the denominator, the answer should be the same as this one, which is 60. Are we good? Or any more questions? Yeah, so you have to plug in those numbers to find out what's the number. Okay. Now That's the beauty using the formula, right? We can easily find out how many like cases if we want to find out using the permutation formula. Everybody, capital P, so we are using notation here, capital P, right? How many cases? If we want to select R out of a total N, that's the formula we are using, right? So P for permutation, right? Using this formula here. Okay, now another example, we say if we want to choose two musicals, right, out of a total line and the playing order, everybody, those keywords here, right? When they say playing order, that means what? Order matters. What that should be? That should be permutation, right? Permutation. We are plugging into that formula. So choosing two out of a total line, everybody? Choose two out of a total line, right? Plug into the formula. We have in the numerator is 9 factorial, right? N factorial. Denominator, n minus r, so it's 9 minus 2. Follow me?